Hello, you guys. Congratulations on getting chosen. Me and Mr. Vargas chose you guys because we think you guys are the most fit for this position. Let's get started with your training. I'm going to start with 3 problems, and my coworker, Mr. Vargas, will do 3 more. Let's get started. Okay, so we have our first problem here. And it says, a recursive formula for the sequence 40, 30, 22.5 is... For the recursive formula, we always have to start the first term. And here it will be 40. So we will do this, 40. This annotation means a sub 1. It just means the first term. And as we can see in our series, 40 is our first term. Now, we're trying to figure it out if this series either is arithmetic or geometric. So the way we do this is we have to rewrite our numbers, 40, 30, 22.5. So we're going to go from the number to the right to the left. So we're going to do this, and then this. So if it's geometric, when you divide the first number on the right to the second number, and then you divide the second number by the first number on the left, and you get the same ratio, it will be geometric. So let's try that. 22.5 divided by 30, it will give us 0.75. Now, 30 divided by 40, it will give us 0.75. So I know now that this series is geometric because it has the same common ratio. Now I know it's not arithmetic because 22.5 to get to 30, that will be 7.5. And then from 30 to 40, it will be 10. Now 7.5 and 10 are not the same, so therefore it's not arithmetic. Now, to put our final answer, we have to put it in this form. So it will be a sub n. A sub n means any term equals the common ratio, 0.75, or 3 over 4, because those equal the same thing, and then a sub n minus 1. And then there you have it. This is your answer. This is the recursive formula for this series, and always have to state the first term. Okay, our second problem is show why x minus 3 is a factor of mx equals x to the third minus x to the second, or x squared minus 5x minus 3. So as we can see, our keyword factor, we can see that this is talking about dividing polynomials, and then let's set it up. So that will be x to the third minus x to the second minus 5x minus 3 all over x minus 3. So for this, it says if it's a factor, and if it's a factor, it doesn't have any remainder. But if it isn't a factor, it would have a remainder. So in this case, I will use the remainder theorem, and which is to do the inverse of the denominator, so equal to 0. So let's set it up. So x minus 3 equals to 0. Then to solve for x, plus 3 equals 3. So x equals 3. Now every time we see an x, we need to replace with a 3. Okay, so we see that we see an x to the third power, so put 3 to the third power minus 3 to the second power minus 5 times 3 minus 3. And then that will give us 0. Because 3 to the power 3 will give you 27, minus 3 to the power of 2, that will give you 9, and 27 minus 9 will be 18. And then negative 5 times 3 will be 15. 18 minus 15 will be 3, and 3 minus 3 equals 0. And that's what we want. Therefore, x minus 3 is a factor. Because there's no remainder. Because there is no remainder. And there you have it. That's how we solve this problem. Okay, this is my last and third problem. And then I'll pass it to my coworker, Mr. Vargas. So it says, if a solution of 2 times 2x minus 1 equals 5x squared is expressed in the simplest a plus bi form, the value of b is. So a plus bi form equals, is about complex roots, which has the real part first and then the imaginary part second. So we'll rewrite this. 2 times 2x minus 1 equals 5x squared. Now, we multiply, and we'll get 4x minus 2 equals 5x squared. Now, we want this to equal 0. So we'll do minus 4x plus 2 and then equals 5x squared. And then that will be 5x squared minus 4x plus 2 equals 0. From there, we can use the quadratic formula. The quadratic formula is x equals negative b plus or minus radical b squared minus 4ac all over 2a. Now, we have to first identify our a, our b, and our c. So the a will always be the number, the coefficient with the x squared, so that will be 5. Our b will be with just the x, and that will be negative 4. And then our c will be just the number 2. Now, we have to plug those numbers into the formula. So, first is x equals, since it's negative b and we have a negative number, then that negative times a negative equals a positive, so you'll put a 4. Okay, plus or minus radical, then you put parentheses, negative 4 over squared minus 4 and then our c will be 2 over 2, and that will be 5. So now we have to solve what's in the radical first. So negative 4x negative 4 to the second power minus 4 times 5 times 2, that would give us, so then we're going to bring everything down, 4 plus or minus, and that will be 16 minus 40 over 10. And then that will be x equals 4 plus or minus, and then 16 minus 40 will be 24. Negative 24 over 10. Now, we have to break down our negative 24 so we can get our b. So, this means that negative 24 so it will be I, the imaginary root, and then 24. So then, two numbers that break these down will be 3 and 8, 2 and 12, 4 and 6. Now, I think there's one more, but now we need to have a perfect square in our radical so we can solve this. So radical 3 and radical 8, none of them are perfect squares, so that cancels out. Radical 2 and then radical 12, none of them are perfect squares, so that cancels out. The square root of 4 is 2. And then we have the square root of 6. So then, now we need to plug that in back to our formula. And that will be x equals 4 plus or minus, plus or minus 2i, because we got our 2, we have our I, square root of 6 all over 10. But we're not done yet because we see that 2 and 10 it could be divided by. So then that would be and also 4. And then that will be x equals 2 plus the square root of 6i, because we can forget our imaginary root, over 5. So our answer will be 2 plus square root of 6 over 5i. But that's not what it's asking for. What it's asking for is the second part, the b, the imaginary solution. So then we can see that the numbers that have the imaginary solution is the square root of 6 over 5. So then our answer would be square root of 6 over 5. That will be an answer. And it doesn't have to include the I because it already has the I and the a plus b I. So it just the square root of 6 and 5. Thank you very much. And now Mr. Vargas can continue.
Hello. So I will take it from here, Ms. Mendoza. So my name is Mr. Vargas, and I will be showing you the next steps on how to successfully complete your assignments or your job or the tasks that are required for this job. So first, we will be starting with an example of dividing polynomials. So first, this is the equation. So it's 2x to the second power plus 5x plus 8 divided by x plus 2, right? So now that we see that this is our problem, I'm going to give an example of how to solve it. So let's keep in mind our our equation, our dividend, and our divisor. So first, our strategy to successfully solve this problem is the box method. So first, we're gonna take the first part of the equation, which is 2x to the second power and 5x, and put it in their respective places around the box. So this just means that this box over here has to equal to 2x to the second power, and these two boxes have to equal to 5x, and this box over here has to equal to 8. So first, after we have placed our numbers around the box, now we put what is being divided by. So it's being divided by x and by 2, positive 2. So then we see what gives us, what number times x gives us 2x to the second power. So that number would be 2x. And whenever you multiply 2x and x, it gives you 2x to the second power. Then we will multiply 2 times 2x, and it will give us 4x. And so that means that we will have to find the number that would add to 4 to give us 5x. Obviously, that number would be 1. So that would be the number up here. So then we multiply. After we multiply, we multiply 1 times 2, which gives us 2. And so we see that this box, the last box, does not equal to the number that is outside the box. So now we have to subtract 8 minus the number inside, which is 6. And then our final answer would be, let's not forget about the 2x and 1. So our final answer would be 2x plus 1 plus a remainder of 6 over x plus 2. That would be our answer to our first attempt. Okay, so this will be your second attempt, or your second example of how to complete your job. So we are going to be solving radicals. So first, this is our problem. This is what we are solving. X equals radical 3x plus 40. We put all of it inside the radical. 3x plus 40. So we take our first step. So we have to get rid of the radical. So this is how we get rid of the radical. Let's bring everything down, and we set it to the second power. So radical 3x plus 40 to the second power. So x becomes x to the second power, obviously, and 3x plus 40 stays the same, just without the radical. So next step. After this, we have to set our equation to 0. So let's rewrite how, as far as we are right now, we are down to 2x to the second power equals 3x plus 40. And so first we subtract 3x from both sides. They are not like terms, so we just move x to the second power minus 3x. Okay, equals to 40. Equal to 40. Then we don't want x to the second power minus 3x equal to 40. We we want the whole equation to equal to 0. So now we subtract 40 from both sides. And seeing that 40 is not able to subtract from negative 3x, because negative 3x has a variable and negative 40 does not. Then we just set x to the second power minus 3x minus 40 equal to 0. So then, now that we have the equation equal to 0, then we just we do this. We are trying to find the answer to this radical equation. So this is equal to 0. And so we have to find the like term, or the common factors, the factors for 40. So the factors of 40 are 8, negative 5, and negative 8, and 5, and 20, negative 2, and so on. And so we're going to pick negative 8 and negative 5. Negative 8 and 5. And so we're going to do these equations. Negative x minus 8 equals to 0. We're going to add 8 to both sides. Do inverse operations. Plus 8. So now we get x equals positive 8. So now that we have one of the like terms, x would be x equals positive 8. Now we do the second term that is an imaginary term. So it's x plus 5 equals 0. Now we subtract 5 from both sides. Now the answer is x minus negative 5. So our answer is 8, because 8 is the only real root. So let's write it like this. X equals 8 because 8 is a real number. Okay. This will be it for this. This will be it for solving radicals. So, the third and last example on how to successfully complete your tasks will be sequences. So, you will be given, I'm going to give you the example of 4 different sequences. So, first sequence would be 16, negative 12, 9, negative 6.75. Okay. So, second sequence would be 1, 4, 9, and 16. So, third sequence would be 6, 18, 30, and 42. Okay, so our fourth sequence would be a half, 2 over 3, 3/4, and 4 over 5. So let's take our first sequence, right? What we're trying to find is which sequence is geometric. So our first sequence is 16, negative 12, 9, and negative 6.75. So how do we find if our sequence is geometric or if our sequence is arithmetic? So what we're trying to find is if our sequence is geometric. So if we divide or multiply and whatever we divide by or multiply by gives us the following number in the sequence, then the sequence would be geometric. If it's adding or subtraction that would give us the next number in our sequence, then that would be arithmetic, which would be wrong, because what we were trying to find is which sequence is geometric. So how do we find it? So first, we take the second term, and divide it by 16. That would equal to negative 0.75. So what I would do in that case would be multiply. We would multiply 16 times negative 0.75. That would give us negative 12, which means that the first sequence would be our geometric sequence. So we are done. Thank you very much for completing this course, and I wish you well in your development as an employee.